Hello all, welcome back. As I said, I'm here to teach you the lab assignment of DDCO, and in the last video we came to know what is DDCO, what is Digital Design and Computer Organization, and we came to know how to use Linux software. In today's session, we'll solve first and second question, and let me first tell you the contents of lab assignment questions. There are about 8 questions, and let me give you the brief description of the questions. Content page. The first question is solve 4 variable expression using appropriate technique. 4 variable expression should be solved using appropriate technique. Here I'll be using K-map. Okay, so I'm using K-map to solve the 4 variable expression, and let me tell you what is K-map as we solve the first question. And the second question is Verilog HDL. And in first question we'll be writing the program and executing it, and we'll be taking the output using basic gates. We'll be implementing it using basic gates. Second question is Verilog HDL program. We'll be writing 3 types of HDL program. One is structural, and the second one is data flow, and the third one is behavioral. Then the third question is to implement binary adder and subtractor using Verilog HDL program. We'll be writing HDL program for full adder, full subtractor, and half subtractor. We'll be knowing what is full adder and half subtractor, what is Verilog HDL as we solve the problems. Then fourth question is to implement 4-bit full adder and subtractor using Verilog programs. Then fifth question is Verilog HDL program. We have to write Verilog HDL program to implement decimal adder. Decimal adder should be implemented using Verilog HDL programs. Then the sixth question is we have to implement different types of multiplexers. There are 2:1, there are 4:1, and there is 8:1 multiplexer, and so on. We have to implement Verilog program for these multiplexers. Seventh question is Verilog program should be implemented for demultiplexer. Demultiplexer is opposite to multiplexer. We'll be having 1:2 demultiplexer, 1:4 demultiplexer, and 1:8 demultiplexer. So we'll be implementing Verilog program for the demultiplexer. And the eighth question is Verilog program should be implemented for various flip-flops. Various flip-flops includes SR flip-flop, JK flip-flop, and D flip-flop. We'll be implementing Verilog program for these flip-flops. Okay, so this is all about the brief and description of 8 questions that you have as your lab assignment. Next, the first question is give a 4 variable expression, simplify it using appropriate technique, and stimulate the same using basic gates. They have given a 4 variable expression f of a, b, c, d, sigma, m, and these are the positions of a K-map, and we have to simplify it using appropriate technique. Technique that we'll be using is K-map, as I said earlier, and we have to stimulate the same using basic gates. Okay, so first of all, K-map is the one which is used to simplify the Boolean expression. It is the method which is used to simplify or minimize the Boolean expression. It is of 2 forms, SOP and POS, sum of product and product of sum. We'll be implementing this using Verilog program. First of all, what is Verilog program? It is a hardware description language used to model electronic devices. HDL, which is used to model or which is used to implement it in electronic systems. Then we have min terms and max terms. Min terms, it is also called as SOP, that is sum of product, and max term is also called as POS, which is product of sum. Min terms are represented as sigma, and max terms are represented as pi in the Boolean expressions. If f of a, b is equal to sigma of some positions, then it is min terms. These are min terms. If it is pi of some positions, then it is max terms. Okay, then we have don't care. We will be using don't care in this question to solve it. We can use the blank cells which are present in K-map in to solve the problem. We can group it, and if required, we can also ignore that cell. This is what don't care means. Okay, now let us write the K-map for the given expression. So they have given it in the position 2, 4, 5, 7, 10, 11, 14, and don't care in the position 8, 9, 12, 13, 15. So this is 4 variable. This is 4 variable K-map. Okay. So let me write or fill the K-map. At second position, at 4th, 5th, 7th, and at 10th position, 11th, 14th position once, and don't care at 8th, 9th, here is 8, here is 9, and 12, 13 and 15. So here are don't cares. So the next procedure is to grouping these ones and don't cares. Okay, so let me group the maximum number. It should be grouped with maximum numbers. It 2 ones are to be grouped, or 4 ones are to be grouped, or 8 ones are to be grouped. So we can also include don't care to have the maximum grouping. So we can group this, and we can group these 8 numbers. Okay, and here 1 is left, right? So we can group this with the corner. This is how we have to group. And we have 1 here, right? So we can group these 4 numbers. So these are the positions 0, 0, 0, 1, and this is 1, 1, and this is 1, 0. Same carry on here. Here we can notice, for this we have to write the expression. Okay, so we'll be getting 1, 2, and this is 3, and this is 4. Okay, this and this will be paired as one term, and so 1, 2, 3, 4. 4 terms will be getting in an expression, in a minimized expression. Here we can notice that A value is changing from 0 to 1. A is changing from 0 to 1, and B is remained as it is. It is 1 and 1 here. So B, and here we can notice C value is not changing. It is constant. It is 0 and 0, whereas D value is changing from 0 to 1. So it is C bar. The expression contains BC bar, first term, okay, plus, and this expression contains, here A value is changing from 0 to 1, whereas B value is not changing, so write B. And we can notice here C value is changing from 0 to 1, whereas D value is not changing. It has remained constant, where it is D. So BD has become the another term for the minimized expression. Then third expression can be, third term can be here 8 grouped ones and don't care. Here a value is changing, a value is constant, here 1 to 1, so a, whereas b value has changed from 1 to 0, we have to not consider the changed value. And here we can notice that c and d value has changed, so the next term is a. Okay, and for this the corner grouped ones, here we can notice that it is a value is 0 and here a value is 1, so a value is changing from 0 to 1, we have to not consider that. B value has remained constant, it is 0, so b bar. Then we can notice that C and D value are constant, it is 1 and 0 throughout this column, so C D bar. Okay, so F is equal to BC bar plus BD plus A plus B bar C D bar. So this is the final minimized expression we got from K-map. We can write the Verilog program. Here it is data flow K-map. This K-map can be any name that we can give. Here inputs are A, B, C, D. Output is Y, or you can also write it as F, as you given here it as F, as we given here it as F. We can write it as F. Okay, so assign, here assign indicates that it is data flow. We can write the program in three types: structural gate level, second one is data flow, and the third one is behavioral. So data flow, in data flow we'll be using assign. Okay, so data flow y equal to or f equal to a single as it is, or plus as it is plus, we can use or operator, and b and c not, right? So complement of c. Okay, then or as it is plus, or then b and d, then or complement of b and c and complement of d, then end module. So this is how we have to write the Verilog program. This is the output. For the value a, b, c, d 0, then y will be equal to 0. For 0 input, then y value is also 0. These normal line indicates that the output is 0. Okay, when a value is 0 and b, c, d value is 1, if the input is given like this, then y value will be 1. Here in the output we can notice that it is a solid line. Solid line indicates that the value is 1, as I said earlier in the previous video. Okay, so this is the output with two conditions: one with all values 0, one with all values 1 except a as 0. Okay, so this is all about first question, solving first question. Second question is design a Verilog HDL to implement simple circuits using structural data flow behavioral model, and the given circuit is this: two AND gates with inputs A and B, C and D, and those two are combined with OR gate and the output is Y. Okay, so first let me tell you what is structural data flow and behavioral model. This is structural gate level program description. So structural gate level program, also called gate level modeling, it describes the hardware in logic gates. We'll be describing and or in terms of and or and so many gates, etc. gates, and how they are interconnected will be described in terms of logic gates in this type of programming. Next is data flow. In data flow we'll be using assign keyword, and we'll be describing the combinational circuit by their functions, like and, or by or. If and is there, we'll be using this. If or is there, you will be using this. Okay, so rather than by their gates, in structural gate level program we used logic gates. Okay, we'll be using and as it is, or as it is, we'll be using the words. But here in data flow we'll be using the symbol of those gates rather than using their gates directly. Next is behavioral Verilog program. It is like C program. We'll be using if, else if, and else statements. Okay, to stimulate and manipulate variables of the data types. This is about structural gate level program and data flow and behavioral Verilog program. By using these three, we'll be writing the program for the given circuit. So the given circuit is this, right? So the given circuit is this. This is structural gate level model and this is data flow. Okay. First thing is module figure. We can give any name for this. It is not only restricted to figure or that. We can give any name. So the inputs are, as we can see here, A is the input, B is the input, C is the input, and D is the input, and output is Y. So write separately input A, B, C, D, and the output is Y. Here let me give the name for these gates as this as G1, this as G2, and this as G3. Okay, the inputs for G1 is A, B, and we have to give output, right? And for G2 it is CD is the input. What about the output? So let me write it as wire W1 and wire W2. Okay, so the inputs for G3 OR gate is wire W1 and W2. So describe it here, declare it here, wire W1 comma W2. And here this is AND gate. So AND G1 of our output is W1 and inputs is AB. Write it W1 output, A comma B are inputs. Then again another AND gate G2, W2 is the output, C and D are the inputs. Next is OR gate. We have A, B plus CD, right? The equation is, the Boolean expression is AB plus CD. So plus OR gate, or G3 of output is Y and write it as inputs as W1 and W2 and end module. This is how to write structural gate level model for the given circuit, simple circuit. Next is data flow. As it is, inputs are A, B, C, D, output is Y. Here we'll be using the symbols rather than gates. Okay, so here A and B, right? Here A and B. So write the symbol AND in between A and B. And C and D, right? Write C and D. What is there in between A, B and C, D? It is OR gate. So write the symbol of OR. Okay, then end module. This is the easiest program. Data flow is the easiest programming method compared to structural gate level and behavioral model. Next is behavioral model. Let me write the circuit once again. Okay, and here we need to know if, else if, and else statement, how they work. Hope you all know what is how if, else if, and else statement works. Okay, so what are the inputs? A, B, C, D are the inputs and output is Y. Here if we know that for AND gate, if any of the input is 0, then output will be 0. If the combination is 0 0, then the output will be 0. If the combination is 0 1, then the output will be 0. If the combination is 1 0, then the output will be 0. If both the inputs are 1, then only the output will be 1. So by writing it in if statement, if both the inputs are 1, if A equal to 1 and B equal to 1, then Y value will be 1. Here it is OR gate, right? So in OR gate, if any of the input is 1, if in 2, one of the input is 1, then the output will be 1, right? So if it is 0 1 or 1 0, the output will be 1. If it is 0 0, then the output will be 0. If it is 1 1, then the output will be 1, right? So here, if any of the input given here, if any of the given to A and B is 1, then the output will be 1. So here the output will be 1. So the input which is going to, one of the input which is going to OR gate is 1. So for OR gate, if any of the input is 1, then the output will be 1. Or else if C and D are 1, if C equal to 1 and D equal to 1, then the output here will be 1. So the input for OR gate is 1. If this is 0 and this is 1, the output will be 1. Or else if A value is 0, B value is 1, C value is 0, D value is 1, then the output will be 0. The output here, it will be Y value will be 0. If we do the vice versa, then the output will also be 0. If any of the input A, if in A and B, if any of the input is 0, then the output will be 0. Y value will be 0. Here also, if any of the input in C, D is 0, then the output will be 0. Okay. This is how to write behavioral model. Let me show you the output here. As I said earlier, if A and B value is 1, then the output will be, Y value will be 1. If C and D value is 1, then the output will be 1. So you can notice here, these are solid lines. As I said, solid lines indicate that the value is 1. Here all the values given are 1. For A it is 1. For B it is 1, for C it is 1, and D it is 1, and the Y value has become 1. Okay, then the another output is if A value is 1, B value is 0, C 1, D 0. A value is given as 1, B value given as 0, C value 1, and D value is 0. Output will be, Y value will be 0. Because AND gate for A, B, if any of the one of the input is 0, then the output will be 0. For OR gate, 0 0. Here also C value is 1, D value is 0. Both the inputs which is going to OR gate is 0. So the output for Y will be 0. A input is 1. B input is 0 and C input is 1, D input is 0 and Y output is 0. Okay, so here you can notice the output. Solid line 1 and 0 indicates this, normal line indicates 0. Okay, so this is all about the second question. Let me explain you the remaining questions in my next video. Keep watching my video and do subscribe the channel for more updates. Thank you.